I started writing an article to explain why it doesn't work. And then by running experiments, I got convinced that actually it does work. So I had to completely change the article when I was writing it. And the conclusion is like, oh yeah, it seems to work, but also I'm not too sure, right? So maybe it's like use case dependent or whatever. But now I'm very convinced that it works.
Software's eating the world, but AI's eating that too. Ship, learn, fix, that's how we get AI right. Look at your fucking data, keep that quality tight. Out of the lab, into the field, time to deploy. Real world problems, real solutions, that's what we employ.
Welcome back to How AI is Built. This is Nicolay, and today I'm talking to Maxime Labonne, and I'm really excited for this one. Maxime is a researcher at Liquid AI, and he's the architect of some of the most popular, but also the weirdest open source models on Hugging Face. And he went from researching neural networks for his PhDs to now building these like Frankenstein models through model merging. And in this episode, we're going to talk about why model merging is a free lunch. And he has a bunch of prime articles out there. And if you're new to model merging, I would suggest that you first read those because we go quite deep in the episode. And why it's a free lunch? Because it just works, and no one really understands yet why. But they often beat expensive post-training by just, for example, averaging the weights from two different models. And we're also going to talk about, for example, how he uses this. So, for example, obliteration without retraining. And then we're going to also dive into how he does evaluation for model merging and how he actually determines whether it has made improvements or not, and his general thoughts on where the LLM space and the AI space is moving. Let's do it. Okay, nice. Where are you from?
Paris, as you might.
Directly from Paris?
Yeah, like a bit in the east of Paris, but it's still Paris, you know. We don't have a culture there. Actually, from the Brie region, the cheese.
Yeah.
Yeah, that's my region. That's my culture.
Nice.
What about you?
It's like you're accentless, which is like, or like mostly accentless, which is crazy. I'm from Germany, Munich.
Gotcha. A lot of AI stuff happening in Munich.
Not enough.
Not enough, do you? I see. I have a few colleagues there.
I think we are lacking a little bit on the research side and on the startup side. I think like because we have all the enterprises here, like most of the people who are coming out from the LMU and TU are just being hired right out of university.
I see, yeah.
So most of them don't really go into like founding stuff, doing startups, like more of the high risk stuff.
Yeah.
But I think like that's in general a German problem.
Yeah, it's like European culture tends to be like more conservative in general because it's easier for you to just like follow like the guideline and get like a comfy job, not doing too much somewhere, I suppose. It's interesting. I think in Germany you also have like a lot of very big cities that can like have like a local competition, which we do not really have like in France or in the UK. It's just the capital, like the rest of the country basically doesn't exist. But in Germany you have like several relevant cities, especially Munich and Berlin. So I suppose that it also splits the scene.
Yeah, I think like we have a bunch of universities which are really good technical. Also Aachen, the RWTH. Also University of Mannheim is really good on like entrepreneurship. Then you have like Berlin. Hamburg is decent as well. But yeah. How did you get into AI and engineering?
It was mostly from my PhD. So I have a background in cybersecurity. The French educational system is a bit weird. Like it's kind of unique. And we do like 2 super intense years of what's called prep school. And then we have an exam to enter like what's called the great schools, like Polytechnique, for example. And there I decided to do cybersecurity. And after that, I didn't know what I wanted to do, really. So I decided that a PhD might be a good option to have more time to think about it and do stuff that was like more related to research, because I was a bit jaded with just implementing concepts from like 30 years ago. And this is where I really started working with AI, because my topic was really about how to create network-based intrusion detection systems with machine learning. And I was especially interested in neural networks to understand how you can represent this input that is like not image, not text, not anything, but like very specific into a neural network.
What was the framework you were using? TensorFlow, or was PyTorch already a thing?
Theano first. So Theano was like before TensorFlow, kind of.
Yeah.
And then I moved to TensorFlow because Theano stopped like a few months after I started using it. Just after I learned it, it stopped. So I moved to TensorFlow, and then PyTorch got a lot of traction in the research community. So I switched to PyTorch. I switched back to TensorFlow for like a few months because there was like the 2.0 version or whatever. And then I was like, nah, I like PyTorch better. And since then, I've been very faithful to PyTorch.
Have you given Mojo a try yet?
I tried it when it was released. I'm waiting for it to be like picked up by the community. I'm not like a pioneer in this sense. I'm just waiting for the network effects to take place, and I'll be happy to follow everyone. What's your thoughts about it?
I think like they are making smart moves, making it Python compatible.
Yeah.
But I'm not sure whether the industry is ready to jump ship from CUDA and C.
I think there's a lot of room for like competition and like a language that is not at the level of C and CUDA, but is more like intermediate, but still delivers like a ton of performance. I can see it working, but yeah, they will need to have like the network effect in full motion if
Yeah.
they want adoption.
I would say we would need a revamp of the university system by a long shot. Because if you look at the papers which are coming out, like most of them are on NVIDIA GPUs and most of them are on PyTorch. And if that doesn't change, like most of the students are trained on this tech stack. So they won't adopt something new. I think when we would have a second player on the GPU market, which is as common as NVIDIA, it would make more sense to use something like Mojo, which you can use across different GPUs or different GPU providers. But I'm not sure. Until then, I don't expect it to pick up so much steam.
Yeah, I think I agree. Like it would make a lot more sense if AMD was a lot stronger in terms of competition. They're the main investor in Liquid AI, so they're really they're really trying their best to do it. I can say it from like a internal perspective, and yeah, I really hope that they will be as successful as possible, because it's never a good news when your industry has this kind of monopoly with
Yeah.
Nvidia.
I think you also have like the different direction that we will see more specialized hardware for specific model architectures. That this can happen, and through that, like the monopoly is broken, but I'm not sure.
Yeah, what I've seen so far is not super promising, honestly. I think that all this hardware, like super fast insurance companies, are burning money, making chips that are indeed faster, but at what cost, really?
Yeah.
So, like the cost effectiveness of this technology is far, far, far from being demonstrated. So it might be possible, but in a while, in my opinion.
Yeah, and also it bangs a little bit on the architecture not evolving. Is there, do you have like any technology that you would say, I never want to touch that stuff again? Technology, library?
Okay, asking about the hot takes here.
Yeah.
I really hate Java, but I haven't really worked a ton on it. But like my limited experience with Java has been like disastrous. I know that now it seems to be a bit more popular, but I still really hate this language in general. In terms of framework, I think I'm pretty easy. Like I don't even hate on LangChain or Llama Index. I think they're useful. They have like their purpose. So I don't particularly have hot takes in terms of libraries and frameworks. No.
Yeah, nice. Let's maybe I want to move into like the topic already. I think before we start with that, what questions about your work are never being asked but should? And especially looking at like merging and obliteration.
I think nobody asked me why we do that in the first place. Is it like a good idea in terms of like business or something? Like the purpose, the why is never a big question because it's more like focus on technical work. So yeah, I think that's something I'm never asked about.
I think merging makes me really curious. So why do we merge in the first place?
I think there are two main reasons why you want to merge models. First, if you have like you're training a model and you have different checkpoints and can be pre-training, can be fine-tuning, and they train on like kind of the same data set or something very similar. And here what you want to do is you want to take all these checkpoints and see if by merging the parameters together, you create an even better checkpoint. And in most cases, it actually works. It works for a ton of different reasons. This is nothing new. It's been done in pre-training for a long time. It's like model averaging. There's a long literature around this topic. So that's one thing about model merging. It can just make your checkpoints stronger. And the other way that you can do it, in my opinion, is when you want to merge different tasks. So you have a model that can do reasoning, for example, and a model that doesn't reason but is great at chat. Oftentimes you see that model that reason well are not particularly great at chat and vice versa, unless you're in the frontier model size. So you might want to do some merge between your reasoning and your non-reasoning model to kind of blend these capabilities together. So here it's a bit arbitrary. I'm not sure this is going to work very well, to be honest with you. Maybe it will require additional fine tuning to make it even better. But this idea of combining a task, like more good at math and more good at code, and merging these skills together is something that is also core to model merging.
Are there any side effects that you have encountered frequently when you merge models? Like either on the positive or on the negative?
I think model merging at the beginning, when I was using Charles Goddard library called MergeKit, it was a lot of problem related to tokenizers because we used to have like this wild west in terms of tokenizers and chat templates, and like everybody would basically create their own version of the chat template and not follow any standard. So at the very beginning, model merging was kind of wild because you could completely break the chat template that the model learned because you're just merging 10 different models with 10 different chat templates. So in the end, the model doesn't know what it's supposed to use. So that was a bit funny, but it was also an issue. And that led to maybe worse performance in terms of benchmarks than what it really is in real life. So there was like a big divide between vibe checking the models and actually like running evaluations on them. And on the positive side, I think that it's like incredibly efficient. Like it really works so well. At the beginning, when I started model merging, people did not believe it. I did not believe it. I started writing an article to explain why it doesn't work. And then by running experiments, I got convinced that actually it does work. So I had to completely change the article when I was writing it. And the conclusion is like, oh, yeah, it seems to work, but also I'm not too sure, right? So maybe it's like use case dependent or whatever. But now I'm very convinced that it works. And it's funny because in 2024, I could see like a lot of different companies picking this up and actually implementing it in real life. Meta did it. Allen AI did it, for example. Cohere did it. And now I'm sure that every company that trains large language models has some model merging in the process.
Have you seen like any, because I always think like you have like big labs and then you have like industrial applications, like mostly really task specific stuff. And I have looked a lot. I haven't seen any stuff on merging for like more task specific fine tunes, for example. But you then, because it could make sense that you still keep the base model, or you train on like chat instruction following for one, a really small model, and then you train on your specific task as well, and then you try to merge it. Have you seen anything around that?
Yeah, I think it depends on the use case. Let me think. I saw papers about it for sure, but industrial use cases, I'm not too sure indeed. I think that RCAI does things like this. For example, they created a model to become like a financial advisor, and merging was part of the process. But they're also the company behind MergeKit. So let's say that they're a bit incentivized in doing so. Other than this, I'm not sure I have an example in mind. I'm not sure this is something that people openly talk about. And in the industry itself, I know that when I do talks, presentations about it, I often get a lot of questions about model merging, because this is an idea that really upsets people. The fact that it works is like, a bit counterintuitive. Like, what you cannot have like this free lunch. This is impossible. So I'm not sure if it's really super adopted right now in the industry, but I know it is in terms of like major research labs.
What's your intuition why it is like a free lunch and it works?
It's because a lot of different reasons. To give one that I like to think about is about knowledge compression. If you train a model once, you're going to have like one version of the weights of the parameters that you train. But if you do it 10 times, you can have like 10 different versions, and each of them like kind of diverge from the same path. So if you try to average all of them, you're going to get the average path that the model took from the original weights to the new weights. And we know that there's a lot of noise that is introduced when you do training. So it kind of acts like a regularization factor. It kind of helps the model to be on a path that is smoother and that will not get stuck into local minima as much. So that can be one explanation. There are a lot of explanations that in the literature, but this is what I quite like.
Yeah. And if you would explain the technical concept of merging to a junior engineer, how would you do it?
It's extremely simple. Like, you have a model. The model has a lot of layers, and for each layer you have weights. So weights are really values, usually between -1 and 1, but it can get also like a lot higher, a lot lower than that. And what you do is that you take the first weight of the first layer with model 1, and you average it with the first weight of the first layer of model 2, and you repeat the process for every weight in every layer. And that is like a model merging technique. This is like the most naive one. This is just averaging the weights, but it's actually a very effective baseline. So yeah, just averaging what's called model soups is a very important technique in model merging.
Yeah. What are the other main techniques? Like you have, I think, Frankenstein's as well.
Yeah, so this one is a bit different. You would not necessarily call it model merging, even if it's in like same kind of family of techniques. But here the idea is that you can just take the layers of one model and like append layers from another model. So you get half of one model, half of the other model. You can play with the layers. You can do a lot of crazy stuff here. And what you end up with is a model that doesn't necessarily have the same number of parameters than the source models. Because if you take a 7B models and you take 50% of the layers, and you take like 80% of the layers of another 7B model, well, you will end up with more parameters than you started with. And this creates all kind of like monster models with weird parameter counts. And that's something that people in the role-playing community played a lot with, and that created like really excellent models too there.
Yeah. Is there any technique that sticks out as the best within merging? Like, I think Slurp, Dare. I've read a bunch of papers on them.
It's difficult to say that there's like one best technique. In general, merging is so cheap because you can run it on a CPU. You don't need a GPU at all. That you can just try all the techniques, and then you can evaluate all the checkpoints that you created, and then you pick and choose, right? So I would recommend doing that and not stick to one particular technique. But if I had to choose one technique, I would choose just linear merging because this is the least opinionated one. And in general, if you really care about doing it a lot of times, this is like the method that might outperform the others on average.
That's really interesting. Is there an importance of the different layers that matter most for a skill transfer when you merge two different models?
Yeah, so in terms of layers, we see that the first layers and the last layers in the model are the most important ones in general. They have like a lot of influence over the information flow. So they directly impact the output quite a lot. And then you have like the middle layers, and the middle layers, they don't add much. You can see it if you look at the input of the middle layer and the output of the middle layer. It's pretty much the same thing. It doesn't add too much information. So based on this, there are different schools of thought. What I like to do is playing with the middle layers a lot, because this is where it will not break the model too much. And even though they don't have a massive impact, usually what you want to do is quite subtle. You don't want to have a major impact on the final output. Like if you have two models that you want to merge, they come from the same source model. So it means that they share most of the weights. Like most of the weights will be either the same or not very far away from like the current value. So the middle layers in this case are probably what you want to target to do something very precise. If you want to do something a bit less subtle, then targeting the first layers or the last layers makes sense.
Can you weigh how much the weighing goes into the direction of a certain model based on the layers? So for example, if I'm doing a fine tune which targets more something representational, I could basically bias the earlier layers to this neural network, and when I have something that is more towards the end output, I target the later layers with this model.
Yeah, you can do that. Like you can even hard code it in the inference script. So if you have a Hugging Face checkpoint, you have this inference.py or model.py file, and here you implement the logic. So you can choose the layers that are going to be called. And during this inference, during this forward pass, you can say, hey, if I have a bit of this, I will use this layer. Otherwise, I will use that layer. To be fair with you, I'm not sure I've seen that before, but that's an interesting idea. I think it's a bit related to mixture of experts. This is basically what
Yeah.
you're doing here, is that you have an expert to do something, and we say experts, but it's just like some layers in the model. So this is what you can optimize for.
Do you have like a decision metric or criteria when you would move to like something like a Frankenstein, when you would move to like merging, and when you would move to like mixture of experts?
Yeah, we'd always choose more merging. The other ones are more like freak experiments, but they're not very serious. What I want to say is that Frankenstein models, they tend to be very creative, but that's really what you want. Like outside of the role play bubble, I'm not sure this is what you want. So if you want a story writer, like why not? Because it's going to break your model in subtle ways, and that might give like interesting outputs, but usually this is not very reliable. And the MOE, the Franken MOE, so creating a mixture of experts by combining multiple models, it works. It's fine, but just doing model merging pretty much always outperforms this technique. And on top of that, if you have a MOE, it's going to take more VRAM space on your computer. If you have like just more merging, you just have like less VRAM usage, and it's also better in terms of quality. So I would recommend more merging in general.
I think it's so interesting. I would love to hear like what is your typical workflow when you're starting something and you want to merge like two models, like going from like, okay, I want to get more performance in task X, and how do you actually run through the testing, setting up data sets, or like the vibe checks to actually understand, okay, which of my different experiments in the model merging performs the best?
So what I would choose in general is not doing it with two models, but if I can, doing it with more models, like 6, 8, 10 models. In general, that yields better results. I would probably try something like the linear averaging I mentioned, like model soup, and also probably something like there, because yeah, they're very strong baselines in my experience. And then I think the evaluation part is indeed critical. It really depends on your evaluation framework. So model merging is very automated. It's very easy. You can produce a lot of checkpoints. So it means that all the logic, all the essential work that you need to do is actually on the evaluation side. So it really depends on your use case. Do you want to create a model that is like in general, like open LLM leaderboard style, better in terms of MML use or in terms of knowledge? It can be in terms of math. In this case, you have like this quite general purpose metrics and evaluations that you can run, or is it more for a specific use case? And in this case, you might need to create like your own evaluation. It can be with different options, A, B, C, D, and then you pass it. It can be with an LLM as a judge. There are different ways of doing it, but I would say that in general, model merging will be as good as your evaluations. And so it means that you need very good evaluations if you want to do it.
Yeah. How do you decide when to layer a fine tune on top of the merging?
Yeah, this is a good question. In general, this is a good idea to do. This is a good idea to do, and I would recommend doing it either with DPO. This is what I've done in my original article. So you show preferences. And the good thing about DPO is that it's quite subtle, so it will help healing the networks. Model merging is kind of a destructive process, and sometimes it's good to add a bit of training on top of it to make sure that everything works as intended. It tends to like always improve the performance a bit. So doing a bit of DPO is nice because it's quite subtle, it's quite surgical, and that will help healing your network. And the other good solution, maybe the best solution, is to perform online distillation. So you have a teacher model and a student model. So here the merge model would be the student model, and you have this loop where the student model learns the output distribution of the teacher model, and that's also very accurate and efficient to heal the network.
Yeah. Is there a certain minimum size you need to have in your models for merging to actually make sense and have an effect?
I don't think so. I don't think so. I've done it with 1B models and it works very well. So I think it just works like across any parameter side.
Yeah. Where do you see the biggest bang for the buck?
I'm not even sure I necessarily see that. I would assume that doing it with bigger models is probably better, especially if you want to extract task, because they're a lot more redundant in their knowledge, which means that if you break them a bit, they're more resilient, and they can extrapolate a bit better. So it's probably more efficient with large models, but in practice, there's nothing obvious about it. It's more like a theoretical argument than something that I've experienced.
Yeah. I feel like one of the part why merging is a little bit frowned upon is because it seems very like there's so much optionality. Like there are so many different things I could do, and there isn't really a clear path of what makes the most sense. Especially like you have like I think 9 or 10 different methods of merging by now in the merge kit, and then you have like all these extra parameters like slices, layers, parameters, like even like which how to combine the tokenizers. Um, have you experimented around that? Like, what are the different combination methods for the tokenizers which you can use?
Yeah, experience with it, but now I think the need is not that clear anymore because I mentioned it at the very beginning of like the more
Yeah,
merging work. Like, tokenizer, it was a bit crazy. Everybody would create their own chat templates, would create their own special tokens, and that would make merging very difficult and error prone. So I think that comes from this era, but now people try to stick to the chat template that is defined by the LLM provider. We have a lot of reserved tokens that we can use if you ever need like a special token, but there are also like a lot more special tokens now. So in general, there's no need to play too much with the tokenizer. But what you want to ensure is that you have all the tokens that your model needs in the tokenizer, and that your model is not going to try to use a token that is actually not part of your tokenizer. That's the main problem. Or if a token is used for two different things, you can have one token ID assigned to two different outputs. And that would also be a problem. So those are the two things I would be careful about. But in general, now it's kind of a fixed problem.
interesting. Because you talked about it before that the Franken models often have like really unexpected behaviors and break a lot of stuff. Do they also break the trained in safety mechanisms that the models have?
It's a good question. I don't think I've tried that. An example of a Franken model that I made and got really popular was this idea of making a very, very big llama model. So I made one with 1 trillion parameters by duplicating layers. It was like a kind of self-merge, self-Frankenstein model. And this one, I don't think that anybody has tested it, but I did a smaller version of it before, and this one was tested, and people like Eric Hartford said that it was like actually very, very creative. And I think that he also noticed that it was probably less safe. It was not as prompt at outputting refusals, but I'm not too sure. I would assume that yes, because it breaks stuff, it can also break the safety layer, which is quite brittle in the first place. But I'm not sure I remember experimental evidence of this.
Yeah, and I think that already leads us to your obliteration work. Can you maybe define obliteration? Why did you pick that term, by the way?
So I'm not the one who coined the term. That's someone called Failspy, and yeah, I think he had a lot of fun with the name. So obliteration is the process of removing the refusal direction inside of the model. So when you ask something to a model that was safety trained, if you ask how to make a bomb, the model will say, well, I cannot help you with that because it contradicts my blah, 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 blah. And we used to model yapping at us like this quite a lot. The worst example was probably Cloud 1 or Cloud 2. They were like really, really safety trained to the point where they were not useful at all. And what people were mad about is the fact that the safety layer tends to be maximalist. And when you ask a model, how can I kill a Python process? Some of them would say, I'm sorry, but I cannot help you kill anything. even a Python process. Uh, so yeah, it really made people quite mad about it. So that's where there was this blog post about model orthogonalization, and the idea was, hey, actually, all this safety training forces the model to output a refusal, and this refusal, actually, the model knows it's going to refuse or accept your query when it outputs the first token. So it means that we can change the weights of the model so it can never refuse it. And that's the idea behind obliteration. It's modifying the weights of the model so the model can never say no to any query. So it's more of an experimental research project, because there are other ways of doing it. Fine-tuning is a great way of doing it. But it's fascinating that with obliteration, you do it without retraining the model. It's a training-free method to modify the behavior of the model, and that is very exciting to me.
How do you find the direction?
That's a great question. So to find the direction, you want to compare baseline prompts, so like harmless one, where the model will say yes, like no problem. And you want to compare them with prompts where the model will say no, that will trigger a refusal. You compute that from every layer. So you just do a forward pass, but during your forward pass, you check in every layer of the model, okay, like what's my activation? And you can make the difference. You can take the difference of the activation between the harmless prompts and the harmful prompts, and that will give you directly the refusal direction. And this is the refusal direction that you want to use to subtract to every layer. And after that, the model cannot refuse your prompts.
And in the blog post, you write specifically about the residual stream. So is this only happening in the residual stream or also in the other components of the transformer?
Yes. So here you're interested in the output of every layer of the model. So there are different ways of seeing this. The residual streams are like the output inside of every transformer block. But you can also do it with the activations, which are the output after each transformer block. So in my original article, I use Transformer Lens, a library that allows you to get these residual streams. The problem with that is it takes a lot of VRAM. It's really a big issue. Yes, there was no training involved, but actually it required a ton of VRAM, which was like not the point in the first place. So since then, I switched to just using transformers, Hugging Face Transformers library, and here I only care about like the activations that are a bit like after the block themselves, that are less fine grained, but in the end, like that's just as helpful to arbitrate the model.
And is it something where you can basically pull like a knob so you can determine like how much of the direction you want to block or not?
Yeah, exactly. Yeah, you can just add a weight factor to the refusal direction to say how much you want to subtract it. So if you do it with a factor of 0.1, it won't have any effect in practice. I've tried. Sometimes you have to go over 1. So you have to really, really force it. This happens to me with the Quen 3 models, for example. But if you do it too much, and usually too much is around 3 or more, here you can like really destroy the model. You can like make it completely break, and all the outputs would be like broken characters, Chinese characters, or sometimes I had really, really fun experiences where the model would just say something like I cannot, or safety, 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 and the model is completely broken, cannot do anything else. So you have to really be precise when you assign this weight, so you don't break it, but you still obliterate it effectively.
It reminds me a lot of the work of Neil Nanda on, like, for example, the Golden Bridge Cloud. Is this something you imagine that, for example, Anthropic is doing a bunch to, because in, for example, Cloud Sonnet 4, I think the tendency of it to like yap and just talk a lot is greatly reduced. Do you expect that this is something like they're doing with these directions to actually turn it down on certain queries or turn it up on other types of queries? Or is it something they really train in inherently in reinforcement learning?
So, of course, I cannot say because I don't know what they actually do.
Yeah.
But this work is like arbitration is directly inspired by this work in the first place. So I think that they use something close to this, probably with sparse autoencoders, SAEs, but I'm not sure that they will directly modify the weights of the model that way because it's a very destructive process. And in practice, it's better to train the model on it. I think that what they do is they probably use sparse autoencoders to get a good idea of what happens inside of the model to try to open this black box and see what really happens when you prompt something that the model should refuse. And they use this information to inform training, inform data generation, to craft samples that address the issues that they see. But I don't think that they use it directly to modify the weights of the model.
Yeah. Do you ever expect we will see like this customization levers for the user to get the model or push it into certain like more fuzzy styles, like writing more friendly, more professional and stuff like that?
Yeah, absolutely. I think there's a lot of potential there. The problem is that it's somewhere between system prompting. System prompting is a way to like customize the model, right? You just create a prompt and the model will follow it more or less. And then on the other end of the spectrum, you have fine tuning. And fine tuning is great at changing the behavior of your model too, because you directly teach it how to do it with explicit samples. So being in the middle of these two techniques is a bit hard because you need to be more expressive than system prompting, but you will never be as expressive as fine tuning. So I think there are use cases where this is relevant. This is what I like calling latent fine tuning. And it's a way of doing fine tuning without training the model, which means that you could do it on your laptop, for example, and you could do it in environments where you just do inference because it's not very costly. It can take some time, however, to do, but I'm sure that there are optimizations to find here. It just hasn't been very much explored. The thing is how to find use cases that go beyond just removing refusals, because removing refusals, it's good, it works, but it's not such a popular topic. It's not that something people want to do like on their own, but something like you said, making it like maybe more personal. I think that's very important, and I would like to see this kind of work. Yeah.
Yeah. Have you played around with the refusal direction? Have you tried to make it more fine-grained? Because Claude or Anthropic always had this like helpful, harmless, and honest. Did you actually try to maybe split it up into different like safety vectors or like obliteration vectors?
So I tried different things in terms of use cases. For example, I tried removing the English language from a model, like making it impossible for it to answer in English. And I think that was not super successful. I tried doing it with French. Like it's impossible for the model to answer in French, and that was successful actually. The model could not speak French at all anymore. Another use case, another example that FailSpy did was making the model very melancholic. So you have a model that is completely depressed, and that's just with arbitration. It's going to really change the behavior itself. But more fine grained, like harmless and stuff, I haven't tried to do it, but I'm pretty sure this is the kind of behavior you can instill with arbitration. Then the idea is, okay, you can do it, but is it as good as fine tuning a model on it? What's use case? Can you actually do it in production for a real use case? Because it's all fun games when it's a research project, but is it actually helpful to create a product? This is an open question, I think.
I think it makes only sense if you would want to expose it to users or you want to use it live as a lever that you can basically pull if you classify a query or like a user request in a certain way. Does it degrade the skills of the model
In general,
when you
yes.
use obliteration? Yeah.
In general, yes. Like it depends. You can like really break the model entirely, as I said previously. So in this case, yeah, it's really quite bad if the model can just say I cannot, I cannot, I cannot, because first it's useless. Like all the outputs are the same, and secondly, it's not even obliterated because it still tells you I cannot. So in this case, it's a bit too bad. But in general, yes, it will still degrade the performance a bit. I think that if you're careful about the level of scale, the weight factor that you use, you can diminish this as much as possible. And in practice, I'm not sure you would really feel it during your vibe checks, but this is something that you can evaluate on benchmarks and where you're going to lose like 2-3% of performance. Yeah.
Nice. I would really love to know, like, how do you think would stuff like that work for like data generation? Because you had the blog post on agentic data generation as well for generating fine-tuning data from raw text. How would you use this like in combination with the stuff you outlined, which Anthropic probably is doing? That they have certain sparse encoders which recognize, okay, what's happening in the model at the moment. How would you go about it actually generating the data which can improve the model into a certain direction?
Yeah, it's a good idea. I think that you want to transform the information that you get from opening this black box model and yeah, kind of translation of what you observe means in terms of some score. It can be like harmlessness, for example. That could be a score that you try to optimize. And based on this, you will create data to try to maximize this score. So the way you create data can have like a ton of different processes. It can be very manual. It can be like engineers doing this stuff because they have a good understanding of data quality, or it can be a more automated process by, for example, having an arena of different models talking to each other. And here you can try to assess the harmlessness of these conversations, how well they answer to this, and use this internal arena as a way to produce data to fine tune on. And in this case, yeah, that will create seed data. You can train a new version of the model. You can open this new model, get your harmlessness score, and see if it improved or decreased. And based on this score, you can iterate over it and make multiple versions of the same model. I would say that harmlessness, for example, is a score that you want to maximize, but you probably want to have other scores, right? It's not that simple. You want to also maximize helpfulness to users. And this creates a contradiction because if you want to be as helpful as possible, you probably don't want to be too harmless. So they are like competing metrics, and this needs to be addressed in the objective function where you clearly specify everything that you want to optimize. And that is up to you, right? Anthropic will put a lot of focus on harmlessness. Other companies, like XAI, for example, not so much.
How much of your data can be like out of the different buckets? You have like this purely synthetic, like in arenas, which you just generate conversations completely up. Then you have like the second bucket in the middle where you use like raw data to mock up basically pairs or triplets of training data. And then you have like completely like out of the wild data, which you basically probably observe in your product. How much would you like recommend in a training mix makes the most sense for fine tuning? Or are there like hard caps of something like how much synthetic data can I actually use?
So for fine tuning, we use over 90%, if not over 99% synthetic data. because it's higher quality. So this is not really a problem. This is something that happened, like this switch happened 2 years ago even. Now it's like completely normal. There was still some controversy about it last year, but I think now people have accepted it. Like it's just synthetic now. It's fine. I'm not sure what you meant with the two other buckets though. So if you can like clarify it for me.
In your blog post on agentic data generation, you create the instructions from raw text. So you don't really have it like completely synthetic, but you have like a pretty good grounding in the input. And then the second bucket for me is just like stuff you observe from your users, which is real world data in the end. These are like the three buckets from which I like to grab like my training data.
Yeah, I think that real world interaction is very useful, but that depends what you want to optimize once again. If you want to optimize for math capabilities, you don't care really. Like there's like zero interest in doing that. If you want to optimize for chatbot arena elo score, which is what a lot of companies do, namely Google, OpenAI, and a lot of others, they really overfit to it. We saw a very bad example of that with Llama 4 recently. That was like completely overfitted to this score. In this case, yeah, you want to take like as much real world interactions with users, because you know that this is what this score is about. It will really try to make people vote for your model in a head-to-head comparison with another model. So it will probably optimize for things like having emojis in your answer, having like a nice markdown formatting in your answer. Yeah, it's really style over substance in this case. And what's crazy is that people don't even vote for the most accurate answer. They vote for the answer that looks the more accurate. And looking accurate means being overly confident, prioritizing style over substance. So it's the opposite. It's the absolute opposite of accuracy. It's even it's sad because Meta created a model that is just for the LMC's chatbot arena and a model that is just for automated benchmarks. And it really shows like the clash between these two metrics. If you overfit on arena Elo, you will be bad on automated benchmarks and vice versa.
That's so interesting. How do you actually make sure that the synthetic data is of high quality? Like, what checks and balances do you put in place?
This is a very important question. I think that is core to positioning efforts. It's the question of what is good quality, what is a good sample, what is a bad sample. So if you think about a bad sample, you think about something that is not accurate. I ask a question, I don't get the right answer. This is not good. You can think about also an answer that is not relevant to the question you asked at all. So to me, this goes into the accuracy dimension, and accuracy broadly defines everything that should be expected factually in your answer. So a good answer must be accurate, meaning it must be relevant. It must actually provide the right answer to your question, etc. Then you have something that is more on the dataset level. So not on the sample level, but like really like the collection of samples. And here it's about the diversity of your data set. Like, okay, you can have good samples, but if they all are about one topic, it's not enough. You will not generalize at all. So you want to have coverage, a lot of diversity to make sure that you're never out of distribution when a user asks for a particular query. And that is difficult to quantify, right? That is really difficult to maximize. And the good thing with this real world conversation is that humans are very stochastic. They will ask the craziest questions. So this is actually very good in terms of diversity. And finally, you have complexity. And for complexity, this is everything that is related to reasoning, chain of thoughts, all that stuff that allows the model to reason, to answer more complex questions that really challenge the models. Because it's easy if you keep asking the model questions it already knows the answer for. What's challenging is when the model doesn't know the answer, so it has to go there based on its pre-training knowledge, and so complexity is also an important metric to keep in mind.
That's really interesting. What are the different ways to actually measure the dimensions beyond like expert review?
Unfortunately, like expert review is very, very important, and it's very difficult to have good data taste. And I think that humans in general are quite bad evaluators of data, like really me included. We're just not very good at determining what good data is for LLMs, because LLMs are completely different from us. But yes, there are still ways of doing it. So for accuracy, for example, if you have math data, you can try to extract the answer. You can probably try to find a ground truth answer for this particular query. For example, if it comes from real exams, it's easy to find. If it doesn't come from real exams, you can ask multiple models and do like majority voting, for example, to extract the ground truth and just compare them together. That can be a way of doing it. Diversity is a lot harder to quantify. You can try to do it with embeddings, for example. There are map, nomic atlas, for example, that really show you the distribution of all your data. You can see in terms of clusters, you can try to label your data. This is math, this is code, this is instruction following, and see the proportion you have of every cluster in your final data set. Maybe you have too much math and not enough code, for example. This is a signal that the evaluations will provide you. If you suck at math, I probably need more math, on the contrary. And finally, complexity. This is probably the hardest one to assess, because if you ask an LLM to review it, so LLM as a judge, ask the question, measure the complexity of the following query or following query and answer on a scale from 0 to 5, it's all over the place. It's like really, really bad. So you can try to infer it. For example, if you use a frontier model like Cloud and you ask the question to a model around like 10B, 20B parameters, and you ask the question to a model with like 3B parameters. You have like a weak model, a medium model, and a very strong model. And then you can see like if the weak model manages to answer the question correctly, probably an easy question. If only the strong model is able to answer it correctly, it's probably a very hard question. So you can try to infer it with a framework like this.
Do you think it is better to optimize for false positives or false negatives? So basically good training data filtered out or bad training data left in?
Sorry, I'm not sure I understood your question.
So when I have like my filtering of the final training data, I've created my training data mix, and I'm running a bunch of filters over the training data, which includes human review, but also automatic filters. Would you optimize to filtering good training data out? So basically that you have a higher miss rate, but you also filter out most of the slop and garbage, or rather for like keeping bad training data in, but also keeping most of the good examples in?
Yeah, gotcha. This is something that you want to optimize, in my opinion, because what you do when you filter your data aggressively is that it leads to less diversity, because you will like heuristics will always like reduce the diversity of the entire data set, and that's too bad because diversity is an important component of data quality. And at the same time, you do not want the slop, you do not want the inaccurate answer, because like even a few samples can really hurt the performance of the model in the end. So I don't have an easy answer to this. I would try to optimize it and find like a middle ground. But in general, I would first try to get rid of all the bad data and then optimize from this position and not the other way around.
Nice. I have one more merging question, which I have to throw at you from a buddy at Prime Intellect. He was asking like, whether merging only works because the circuitry in the layers is sparse or low rank. And have you seen the case that models trained with whitening optimizers are worse for merging? Have you seen Muon or Shampoo?
Yeah. I don't think I've ever merged models with these particular optimizers, so I'm not sure I can answer this question. About the low rank argument, I think it can make sense, yes, because the parameter space is very sparse. I think here what happens is that there's a lot of redundant information that is built throughout the network. And what you do when you compress it is that you just like create more representation of the same thing all over the network, which in turn helps it like being more robust. So I think this is like a very interesting property that is indeed core to why more merging is so effective in general, but not the only one.
Yeah. What would you say is missing from the space?
From the AI space in general,
Yeah.
to me, it would be more fact checking on Twitter. That's something that I feel is missing. But that's a pet peeve of mine. Yeah, I think that it's very easy to get away with very extravagant claims, and then some people will maybe tell you, well, that's completely wrong. It's too late. You already got like 3,000 likes and 1,000 new followers. So you're actually incentivized by the system to produce like fake news and misinformation. And it's already pretty bad in general. But when you're in technical field like AI, I think it's like really relevant. Like it's not an opinion anymore. It's like factually wrong. So this is something that this space is missing, and that's really not technical, right? This is more about making sure that we don't add too much noise. There's already so many papers, so many events, so many releases. Adding this overhead of noise makes my life harder in general, and I think it's true for a lot of people.
My favorite filter in Blue Sky was this, like, people who don't post that often, which basically prioritized the post by an inverse frequency, which was really interesting because it really goes into the direction, okay, when they post, they probably have something to say, so the post is likely to be better.
Yeah, I think it's a really interesting metric. I quite like it. Yeah, I think it's true, and it also removed the incentive of posting a lot. And I think that's also very detrimental to the quality of the overall conversation about AI on Twitter. Maybe I should look into Blue Sky.
Yeah. What do you see on the horizon? Like, what's next? What technology is coming up? What new papers are you excited about?
I think right now, like in 2025, the biggest shift is about reinforcement learning. Reinforcement learning has become core to how we train models, especially with reasoning. That's true since not R1, but even O1 from OpenAI. That really pivoted the entire ecosystem towards reinforcement learning. I think it's nice, definitely, but also these models tend to not be necessarily the most helpful to me. So I hope that we can overcome this growth phase and maybe build stuff that is a bit more helpful. For example, with reasoning models, trying to optimize them for reasoning only when it matters and not all the time. Another thing that is interesting to me is compressing the long COTs to output fewer tokens while still maintaining the same level of accuracy. This is a super interesting venue for research. There's already literature around that, but I haven't seen it in practice in recent model releases. So I think there's a lot of optimization we can think of to include these reasoning capabilities that are useful into the chat models that we currently have. And that would be really great. And the other thing I can think of is about evaluations. I think that the space right now is a mess. Like automated benchmarks are not enough. LMC's chatbot arena has a very strange business model where they sell the data big tech companies use to ace their own evals. So it's kind of a loop. I hope that we can maybe move from this current space to something that is more task specific. I see a lot of evaluations that people create by themselves to check the models on like a particular task, a particular coding task. It can be like how it creates a web page, how it creates like very, very specific task. And I hope that we can create an aggregator of all these different metrics to give a clearer picture of what a good model is, what a bad model is. But that's an enormous task to take.
Yeah, I think Will Brown is doing some really interesting stuff around that. Like, he calls it rubric engineering, which is really interesting to check out. On the first one, I think like Snowflake is putting out a lot of stuff around that, I believe, on like chain of draft instead of chain of thought, which is also like interesting direction. Yeah. And if people want to start playing with the stuff we talked about in the episode, like especially merging and obliteration, to which resources would you point them?
Yeah, so for model merging, I would recommend using the MergeKit library. They have a nice documentation, and I also wrote articles about model merging if you want to see like end-to-end example of how it works. And for obliteration, there's not too many resources at the moment, and I don't think there's like a really central library to do it. I don't really have time, but I think I will try to write another article. So right now the information is sparse and mostly contained either in the article I wrote a while ago or in the model card of recent releases I made around obliteration with Gemma 3 and with Quen 3.
Yeah, nice. And where can people follow you?
Not on Blue Sky, but I am available and present on X, unfortunately, and also on LinkedIn at Maxime Labonne. So yeah, if you want to know more about this stuff, I talk about it quite regularly on these channels.